Okay, another short video here. Tried doing this before and I was over the 15 minutes. Want to talk today about the water cycle, or some people will call it the rain cycle. Basically, how water cycles through our environment. There are trace amounts created and destroyed in various chemical processes, but in general, if you look at water as a whole, it just cycles through our system and, doesn't really change. Basically, for all intents and purposes, we have as much water today as we had yesterday, and we will have as much water as tomorrow as we do today. A little bit more might be frozen as ice or whatever, but in general, water, H2O, we have a set amount on this planet. People misrepresent that as saying we're running out of water. It's just we're running out of clean water, and we're polluting bodies of water, and even though more rain's coming in, the rain gets polluted whenever it enters the water that's already polluted, and that's a whole other topic. But at any rate, starting with a drop of rain. A drop of rain falls to the ground. First thing it's going to do is hit vegetation. Normally this is visualized as trees. It can be grass, can be whatever. To some extent that it can even be buildings, although buildings aren't really great for it. But first thing that happens is things get wet, and that takes up a certain amount of water. Imagine like if somebody shoots you with a squirt gun. You get wet, but it doesn't drip on the floor. It uses up a certain volume of water, small, but when you take into account something like a tree that has a massive surface area on all its leaves and branches and everything, it adds up to a small but measurable amount. Now, rain keeps on falling down. Once it passes this level, it starts going down to the ground and wetting the ground. Now, when you reach the ground level, it's going to start splitting into two paths. Now first, it's going to, dampen the surface of the ground. And in a totally natural environment, you've got a pretty thick organic layer. Pine needles, leaves, dead grass, whatever the hell it is, that acts like a sponge and will soak up an awful lot of water. But sooner or later, that becomes saturated. When that becomes saturated, it starts traveling down into the soil. Now, if it's raining past a certain rate, a certain portion of it is going into the soil and another portion is going to start running off across the ground. First, I'm going to talk about the portion that is soaking into the ground. Now, it's going to soak into the ground at a certain rate depending on the type of soil, how compacted it is, and many other factors. And it's going to go down relatively slowly. Even if you've got sugar sand in Florida, if it's pouring, most of the water's running somewhere rather than going into the ground. It goes down until basically it hits something that slows it down or stops it. A lens of clay, bedrock, something like that. It'll go down there until it hits that. Some of it will stay in the soil because it absorbs a little bit of stuff like a sponge as well. And that is used by plants, and the plants will soak this back up. A process called evapotranspiration. Basically, they're giving off water vapor through their leaves, which kind of sucks up with, it's called capillary action, basically like a straw through their cambium layer, and sucks up water or nutrients from the soil. A lot of people overemphasize that. They do a lot in the course of months and years, not so much in the course of a single rainstorm. At any rate, the part that hits they call it impermeable, something that basically stops the water or at least severely slows it down, the water will start going sideways through the soil. If If going sideways is easier than going down, the water goes that way. Always path of least resistance. So the water will basically follow the contours of whatever's under the soil, the bedrock, usually downhill. Basically, it'll go over and down, and eventually this goes at a very slow rate through the soil until it comes out in the open through a seep or a spring, or sometimes it runs into a body of water. You know, it runs into the channel of a creek or a river or the floor of a lake, whatever. But you know, the groundwater just continues until it comes back above ground again. The water underground is called an aquifer. It's like an underground watershed. The water that continues over the surface, now it's going to try finding its path of least resistance. It's going to kind of pond and puddle in little nooks and crannies. You know, in an urban environment, basically it hits pavement and it's gone. In a natural environment, though, it's going to take time to go over the little unevennesses in the ground, go around sticks and rocks and logs and whatever. And a lot of these things, that's part of your organic layer that's, you know, soaking up water and storing it. And eventually it starts to accumulate into what we call shallow concentrated flow. It's not really in any kind of a real, you know, temporary stream or anything yet. It's just kind of, you know, it's downhill from the bumps around it, basically. From there, it'll eventually hit some sort of a channel. In the stormwater profession, they always call these things swales. I don't know who liked that term, but it seems to be universal, but not used outside of the engineering profession a whole hell of a lot. But, you know, any kind of a ditch, basically, it'll collect into a ditch. And, you know, in a natural environment, these ditches even are kind of rocky in the meander and everything. So kind of slows the water down, but still it keeps on continuing its way downhill until it hits, you know, a permanent stream, and then a bigger stream, and then a river, and then on to the ocean, unless you drain to the Great Salt Lake or something landlocked like that, you're going to the ocean. Things that affect this, like I said before, soil compaction, development. A nice level mowed lawn produces a hell of a lot more runoff than a natural forested area where it's all moss and logs and rocks and bumps and everything soaks up water and nothing really creates a very good path for the water. You know, our towns and cities are designed more or less to drain. And paving doesn't really, you know, it puts a lid over top of that soil. So instead of going down, it's got to go across your driveway and across the streets and across building roofs and everything until it hits some sort of an inlet, and, you know, it goes shooting through that. When you get into a storm sewer, the pipes are very smooth and round and everything, a lot different than they would be for a natural stream channel. This creates a flash flooding event. That's part of why flash floods happen in deserts more than they do in forested areas, because deserts don't have as much vegetation. A lot of times they're rocky. They don't have as much to absorb the rain. In urban environments really create that. The more urbanized an area is, the more flood prone it is, just because all the rain gets to one point at once, whereas, okay, it rains over a broad area and it's all natural forests or grassland or whatever, you know, the water falling right next to the body of water gets there kind of fast, but the stuff that's a little bit farther back takes a while to get there, and the stuff that's at the farthest reaches of the watershed, you know, it can take hours, it might take days to get there. Whereas, okay, you cut down all the trees, you build all these little yuppie domes and everything, and you put in roads and storm sewers and everything. What used to take days to get to that stream channel might get there in hours, sometimes in minutes, you know? So it all ends up there at the same time, whereas in the natural environment, the stuff that landed close to the creek would have been in the creek and gone already by the time the stuff from the farthest reaches got there. You know, when it's all getting there at once, makes more for a flash flood. Also, the more pavement, etc., the less water is able to sink into the soil. The more water that goes into the soil and goes into these aquifers, the more base flow. So in general, your creeks and streams in a natural situation compared to an urbanized situation, they've got more water when it doesn't rain, and they change less when it rains compared to an urbanized stream where they usually have a lower base flow level. And you know, you see some fairly large creeks that if we don't get rain for a couple months, they're almost dry. And that's why the urbanization really does that on the groundwater end of it. And then on the other end, you know, when you do get one of those cloud bursts, all that water just comes through there. It's like a little mini flash flood, and you know, we got creeks around Pittsburgh that have problems like that because it's a hilly area and it's a very urbanized area. So a lot of places that, you know, if you visited here 200 years ago, probably would be, you know, not as much affected by an equivalent storm, are now having these, you know, major flooding events where they're coming out of their banks and going on the roads and things like that when we get, you know, like 2 inches of rain in a thunderstorm or something like that. And of course, all along the way, I briefly mentioned the evapotranspiration, the plants using the water in the soil, but of course, all along the way, the surface of all your streams and rivers and lakes and everything else along the way, wherever the water is exposed to the air, it's evaporating and going back up into those clouds to come back around as rainstorms somewhere else. In some places, you know, more moisture gets into the air how I say it, more fast flowing water, just because the water gets mixed with the air a little bit more for the same amount of temperature and everything else. You know, there's more surface area of the water exposed to the wind when it's tumbling over rocks, etc. But at any rate, that's a brief overview. I don't want to run too long going into the specifics of any particular parts of it. Let me know in the comments below if you want to have any more detail on any particular parts of this. Hopefully it gives you an idea of how this stuff kind of sort of interacts and some of the causes and effects, and talk at you later.